Welcome to Study Loop.
We have resistivity rho equals to 2300 ohm meter and electric field amplitude E naught equals to 0.450 volt per meter. Okay, so for the part A of the problem, in which we have to determine the current density, and current density JD is given by E naught by rho. Okay, so substituting the values, we get 0.450 divided by 2300. Okay, so substituting the values and after solving it, we get JD equals to 1.95 multiplied by 10 to the power minus 4 ampere per meter square. Okay, so this is the answer for the part A of the problem. This is current density. Okay, so now moving to the part B, in which we have to determine the current density in the maximum condition. Okay, so current density is also defined as JD equals to epsilon dE by dt. Okay, so the equation of electric field E is given as E equals to E naught sin omega t. So from here we get dE by dt equals to E naught omega cos omega t. Okay, so now JD comes out to be to take maximum value, this cos omega t must be equal to 1. So we will get only epsilon and E naught multiplied by omega. Okay, so now omega is equals to 2 pi f. So epsilon multiplied by E naught multiplied by 2 pi f. Okay, and at maximum condition epsilon is equals to epsilon naught. So substituting all the values, we get JD equals to epsilon naught is 8.85 multiplied by 10 to the power minus 12 and E naught is 0.450 and 2 pi multiplied by frequency f is 120 hertz. Okay, so from here after solving it, we get JD equals to 3 multiplied by 10 to the power minus 9 ampere per meter square. Okay, this is the answer for the part B of the problem. Now this value is much less than the value obtained in the part A. Okay, so now moving to the part C, in which we have to determine the frequency at the maximum JD condition. So JD is equals to epsilon naught E naught multiplied by omega. Okay, so JD is equals to also E naught by rho equals to epsilon naught E naught multiplied by 2 pi f. Okay, so from here frequency f comes out to be E naught by rho divided by epsilon naught E naught multiplied by 2 pi. So substituting all the values, we get E naught is equals to 0.450 divided by 2300 divided by epsilon naught is 8.85 multiplied by 10 to the power minus 12 and E naught is again 0.450 multiplied by 2 pi. So from here after solving, we get small f, frequency f equals to 7.82 multiplied by 10 to the power 6 hertz. Okay, so this is the answer for the part C of the problem. Okay, this is the frequency for the maximum condition. Now moving to the part D, in which we have to determine the phase angle. So as we have equation of E and dE by dt before, so by seeing both the equation, we can see that E is equals to E naught sin omega t and dE by dt is equals to E naught omega cos omega t. So both functions have sine and cos function, so both will have relative phase of conduction and displacement current will be 90 degree. Okay, so the phase difference is 90 degree. So this is the answer for this part. Okay.